Hello, my name is Dr. Dayan Goodenowe. Today, we're going to look at the blood results, ProdromeScan blood results for Ben Greenfield before and after taking a round of supplementation that included the Plasmalogen precursor supplement called Prodrome Neuro. So very, very exciting stuff. But before we get into the overall blood work, let's take a look at a reminder of what ProdromeScan is all about. So I'll give you a little bit of a background on the philosophical basis of ProdromeScan. We're talking about immortality science versus mortality science, health versus disease. And typically we forget about disease until it's upon us, but disease does not happen randomly. There's always a precursor to disease, and that precursor to disease is the prodrome of that disease. We see biochemical changes in our body before we actually get a disease. So at some point in time, we're healthy, and most of us are healthy for many, many years before we get sick. And that healthy state will transition into an at-risk state, like people with type 2 diabetes or early stage cardiovascular disease. We acquire these biochemical dysfunctions as we get older, and randomly somewhat. So we acquire a biochemical deficiency, and this creates a disease risk. It doesn't mean we have a disease right now, but it means that we are at risk for a disease in the future. Sooner or later, if that risk is not modified, that risk will eventually result in the pathological manifestation of a disease. And now you actually have a disease. And if that disease is not treated effectively, that disease will ultimately end in death. And like none of us live forever. So this is typically the cascade of how we go from the healthy, vibrant state to death. And this can happen very quickly, or it can happen very slowly. Now, the current medical practice focuses on treating the pathological manifestation of a disease. We're here to prevent you from dying. And this just resets the biological clock and puts you back in the risk category, but not yet in the pathological disease state. And I call this mortality science. So mortality science is a science of treating disease symptoms to delay your death. The next best thing is basically preventative medicine. So disease science is a science of treating disease prodromes to delay disease. So if we correct the biochemical prodrome of a disease, okay, we can restore you back to the healthy, low-risk category. So if you're a type 2 diabetic and you take diet and lifestyle modifications to restore your glucose sensitivity, okay, you remove your risks that are complications arising from type 2 diabetes. So this obviously is a good thing. And that's focusing on diseases. How do we identify disease and bring you back to normal from the disease? Immortality science is really the science of iterative functional maintenance and optimization. It's the science of not waiting for disease to occur. Immortality science is ignorant of disease, death, and time. It's entirely focused on function. Are our biochemical systems functioning, yes or no? And if no, how do we make them optimal? Pretty simple and straightforward stuff. So ProdromeScan is basically designed in that manner. It's not designed to diagnose a disease. It's designed to evaluate the operational systems of your body. What are the key biochemical systems? And it's designed to help create biochemical reserves in terms of your fuel tanks. Make sure your biochemical reserves are sufficient. That's the biosystem sufficiency categories. And the second one is biosystem function reserve capacity. That is, are your biochemical systems, do they have excess capacity for when you need them for a rainy day? And that's what this is all about. So it's kind of a hand-selected mix of biomarkers that help us identify how your biochemical systems are all balanced. The key point then is that every biosystem described in ProdromeScan can be optimized by targeted environmental interventions, your diet, your lifestyle, your supplements. So the time to optimize your biochemistry is now. So we're going to look at how Ben's biochemistry changed from his original blood work to his future blood work following dietary supplement regimen. I haven't talked to Ben, so I don't know all the other aspects of his lifestyle that have changed before and after. So the key phospholipids, if you remember the first blood work, and we have a video on his first blood test results as well. So just to make it simple, I'll just put the percentiles in his before and after. So this is his first blood test that was done late last year in 2020. And then this is one that we just received about a month ago. And before, this was his blood work, and then he took Prodrome neuro supplementation, some mitochondrial support, and acetylcysteine, carnitine, some creatine into his diet, and some Cerephos and alpha GPC. So a few supplements to basically enrich his underlying biochemistry. So his baseline results are here. So at baseline, he had low levels of plasmalogen. So this is talking about all of our phospholipids, the key membrane phospholipids that make up the cellular boundaries of all of our cells in the body. And the two main classes are the ethanolamine phospholipids and the choline phospholipids. Those make up the bulk of all the membranes of your body. And within each of these classes, the ethanolamine class and the choline class, there are the phosphatidyl, which is the traditional phospholipid, 100% obtainable from the diet. And then there is the plasmalogen. And the plasmalogen is a unique phospholipid that has a special bond called a vinyl ether bond. And also what's special about it, it's fundamentally not available dietarily. Your body must make it. Your body makes a lot of it, and your body uses a lot of it. So 20% of your brain, high levels in your heart, your lungs, your kidney have this plasmalogen molecule in it. The very last step in their biosynthesis creates a bond called a vinyl ether bond, and it's designed specifically to be sensitive to acids, specifically peroxides. And so your body consumes plasmalogens when they neutralize reactive oxygen species. But they're also critical for membrane fluidity, protein function within membranes, and really very important in your neuromuscular junction and the neuronal synapses of your brain. So those things are described in much greater detail in other locations. The point here is how the ProdromeScan test, it's designed to be really, really personal. You're compared to a reference population, but what's more important is how your individual systems are behaving in relationship to each other. And so in his baseline blood work, his plasmalogen levels were low relative to his phosphatidyl levels. And this could be due to impaired manufacturing of plasmalogens, or it could be due to excessive consumption of plasmalogens. So it's a mass balance equation. And so he's a young guy, very healthy guy. And so this is probably due to overconsumption. So he was somehow consuming a lot of plasmalogens, probably from his extreme sports activities. And you'll notice that the choline and the ethanolamines typically follow each other, okay, to a certain degree. And so, and then also his DHA levels are, the DHAs are very long chain polyunsaturates that give your membranes a lot of fluidity. So one of the things with the low levels of plasmalogen was taking the Prodrome neuro supplement, which is a plasmalogen precursor, and it actually has DHA in it. So the molecules that are in Prodrome neuro are actually 2C and 2D, and 4C and 4D. So these are the these are the metabolic byproducts of taking Prodrome neuro. And you can see that those two molecules went dramatically improved. And his total pool of plasmalogens went from 29% to 75%. So that's extremely good. So now his plasmalogen pool is high relative to his ethanolamines. He was taking some Cerephos to maintain his ethanolamine pool, but that's still low. So he'll actually need more seraphos and to maintain that head group of the ethanolamine. But his choline pool remained very nice. So it still went from 81 to 68. So his choline pool went down a little bit, but his plasmalogen choline pool went up a lot. And I'll show you that in the next part when we talk about methyltransferase activity. So take-home message here is we definitely have him on the right track. We want him in this space. So the plasmalogen precursor supplement is doing exactly what it was intended to do. Now, the next section in the ProdromeScan report deals with your dietary fatty acids and your dietary fatty acid ratios. There's 3 essential fatty acids in our diet supply. The omega-9, which is like our oleic acid. So 18-1 is oleic acid. It comes from our olive oil. 18-2 is your omega-6. It's called linoleic acid. It comes from corn, soy, canola oil. And that's that molecule gets used for multiple purposes. It's critical for cholesterol transport, but it's also used as a precursor to create your polyunsaturated fatty acid called arachidonic acid. And the third essential fatty acid in our diet is the omega-3. Dietarily, from plants, it's an alpha-linolenic acid, something like flax oil. But that doesn't stay in that form very long. It gets converted. And the purpose of those omega-3s is to make this final molecule called DHA. And DHA is a long-chain polyunsaturated fatty acid, and it gives our membranes fluidity. And so 22,6 is 22 carbons, 6 double bonds. So there's 2 pools of phospholipids here. The ethanolamine pool, and you'll see 18,0 is the same in all of these, so we can look just at the fatty acid changes. And in the phosphatidylcholine pool, this 16,0 stays the same, so we're just looking at the changes in the fatty acid on the phospholipid. This gives us a very accurate representation of what is going on in Ben's body. And so at baseline, he had a fair bit of his arachidonic acid and DHA levels were kind of balanced, but not where we want them. We want the DHA levels high, arachidonic acid low. And same thing here with the phosphatidylcholine. The body will make arachidonic acid when it doesn't have enough DHA. So DHA is the preferred membrane molecule for fluidity. Your linoleic acid is kind of your Inspector Gadget fatty acid. It can be used for oleic acid type purposes, and it can be used for omega-3 like purposes. But this is exactly what happens when you take omega-3 supplements. So Prodrome Neuro is an omega-3 supplement. It provides very bioavailable DHA. And this is what you should see. You should see the DHA portion of this pool go up, and it'll push the arachidonic acid pool down. Because the reason this arachidonic acid was high is because his body was making it because he didn't have enough omega-3. So, and that'll also result in your omega-6 being preserved. And same thing here. So omega-3 went up, omega-6 went down. The arachidonic went down, and his short chain linoleic acid is preserved. And then also his oleic acid gets preserved. This is perfect. This profile right now is almost textbook. Okay, so he should just keep doing exactly what he's doing and maintain that level. When you have DHA in your membranes, it's a low inflammatory state. And you'll see the difference in the next page. Now, the other things we look at is iron levels and his GTAs. Now, he had normal levels of GTAs, and they decreased from last year to this year. I have no idea why that happened. This is not exactly really common. Your GTAs are made by your gut microbiome, and then they're absorbed into your blood supply. They're very potent anti-inflammatories, and they're also potent anti-cancer molecules. And typically, they're pretty stable over long periods of time. And so he want to follow up on this in terms of his gut health. So I don't know anything else more than that. We do have a supplement called Prodrome GTA, and it's not the exact human equivalent of GTA. It's a mimetic. Curcumin has, like turmeric, has a class of bioactive molecules called curcuminoids. And there's 3 of them, curcuminoid 1, 2, and 3. The third one is called BDMC, and it has some very potent properties. And the biological activity of that third curcumin is very similar to the endogenous GTAs. And so we found a supplier, and we provide a supplement called Prodrome GTA, which has high levels of this BDMC. It's a very potent anti-inflammatory that people can look into. His iron was borderline. His iron is perfect now, so I'm very happy with that. So next, we move on to the second page of the ProdromeScan report, and we move from overall sufficiencies to functional reserve capacity. So in the previous page, everything looks really good. He should probably take some more ethanolamine, more Cerephos, and maintain his choline levels, and that will continue to stay in their healthy range. Now we're going to look at 4 systems here simultaneously. The first one is the methyltransferase system. Typically, the biomarker is homocysteine, and homocysteine is a measure of your methyltransferase activity in the body. So your body has hundreds of enzymes that have to methylate things. The 2 main ones is making creatine for your muscles and making choline for your membranes. And when your methyltransferase system gets overactive, it has negative feedback and it shuts methyltransferase activities down, which you don't want to have. You want to preserve capacity. So he starts at 6, he's at 9, so he's still in that good space, basically anything under 10. And we see this sometimes when we're supplementing with the plasmalogen supplements, because the choline plasmalogen is primarily manufactured by methyltransferase of the ethanolamine. I know this is kind of gobbledygook stuff, but so you want to make sure you maintain that. But overall, you can see that his phosphatidylcholine levels are elevated relative to his ethanolamine, and this is a methyltransferase system. So he's taken some alpha GPC, which is great, so he's supplementing his choline, but he's still consuming ethanolamines. So look at his ethanolamines went from 52 to 25. So this is he's consuming them. He's making choline, and that's also being observed. So his phosphatidylcholine levels are being preserved because he's taking alpha GPC, which is excellent. But his sphingomyelins have come down because, again, he's consuming a lot, which is fine. He's still got capacity. So this would just mean keep up on the food, basically, the ethanolamine. So the Cerephos and the alpha GPC, and this should normalize itself over time. Now, mitochondrial function, this is really nice. So he had quite a bit of oxidative stress going on. So his C-reactive proteins was really, really high. It was around 7.8. Okay, so something was going on back then. And this is indicative of his mitochondrial function. So his mitochondrial function, so this is a very simple, crude mitochondrial function test. So your mitochondria are your energy burning cells, organelles of every cell. And their purpose is to take a little molecule called acetyl-CoA and convert it into carbon dioxide and water. Just like your car engine burns hydrocarbons. And it takes the energy from that burning process to make your energy molecule called ATP. I tell people the human body is essentially the same as a hybrid electric car. We basically have a hydrocarbon burning engine that we use to charge a battery. And the battery we charge is the electron transport chain. So it's physically, it's a battery. We have a proton gradient. that your body creates, just like a battery. And it uses that battery energy to drive a pump called the ATP pump, adenosine triphosphate pump. And ATP is the energy molecule that your body uses for everything. And you make a lot of it. Like you make about 170 pounds of ATP every single day, like your whole body weight of ATP. So this is an incredibly active biological process in the human body. And so that's what we do. And so the mitochondria is both the hydrocarbon burning engine, and it is linked, if you will, to the battery, which is the electron transport chain and the proton gradient, and that's what it does. And if it gets overheated, it starts leaking out acetyl-CoA, and this is what happens. So now we had some adrenic acid leakage. He had conversion of linoleic to arachidonic acid. This is fatty acid elongation. And now we have a beautiful product. Like this is perfect. This is textbook right now. This is perfect mitochondrial function. His mitochondria are just tight. Acetyl-CoA is coming in, carbon dioxide and water is coming out. And look at the C-reactive protein levels. Went from 8 to 0.5. So he's perfectly where he wants to be on the inflammation state. Prodrome Neuro seems to do this like clockwork. If you have high C-reactive protein levels, the DHA plasmalogen just knocks C-reactive protein back into normal. So everything here is very, very happy. He needs ethanolamine. He needs more ethanolamine because he's consuming a lot of ethanolamine. And so we want to give him probably even more Cerephos than he was taking previously to keep these levels up. And his alpha GPC. See, his alpha GPC is doing the job. His choline levels are nice, but his ethanolamine levels are still too low. So that's it. So his elongase looks great. So the next thing we look at is the peroxisomal function and his cholesterol transport system. So in the past, so previously, he had this, so these first 4 lines are reproduced from the first page of the report. And in his previous blood work, he had these plasmalogen levels were low relative to the phosphatidyl, okay? But the second part of this test deals with peroxisomal beta oxidation. And it looks at the relative ratio of DHA, which your body still makes, but your body converts DHA to EPA through a process called peroxisomal beta oxidation. And that's an indicator of how well your peroxisomes are working. And peroxisomes are really one of the biggest things that we deal with for health, diet. When we're fasting or we do resistance training, we're stimulating peroxisomal function, and that's really burns our triglycerides. And that's, so when you exercise to lower your triglycerides, fundamentally what you're doing is you're stimulating peroxisomal function, because that picks up the extra slack of fatty acid metabolism. So previously he had these low plasmalogen levels. His beta oxidation was kind of balanced a bit here, but his triglycerides were high, okay? And so this meant he was overheated. So this high triglyceride level here was fundamentally due to his mitochondrial function problems that I showed you in the previous slide. There's 2 organelles that burn your fat. One is your mitochondria, and the mitochondria burn pure saturated fat, like palmitic acid is what comes, like we store that in our adipose tissue, and it's pure fuel. So but your peroxisomes are usually they process the very long chain fatty acids like DHA and other more garbagey fatty acids. And if your mitochondrial function is impaired, then your peroxisomes end up doing part of the job of the mitochondria. They're supposed to be both working together to metabolize your fatty acids. So now, okay, his plasmalogen levels are up, okay? His DHA plasmalogen are excellent, okay? And so his EPA levels are up, so he's making it. And here on the phosphatidyl pool side, you can see the balance is a little bit different, but the relative ratios are here. But his triglycerides have come way down to 76. Okay, this is perfect. This right now, other than his low ethanolamine pool, we're pretty happy with this part. which leads us to the whole cholesterol regulatory system. Okay, and so his cholesterol's come down a little bit. His profile before was still pretty good. Like I don't mind 250, like anything over 200 is good. HDL in the 60s. His HDL is creeping up to a little bit high for a man. Okay, so he's kind of overheated a little bit here. When he's peroxisomal function is good. When you have high HDL, that's the cholesterol export from your cells. And low LDL, just let me back up a second. So when you look at cholesterol regulation, there's really 2 or 3 things to focus on. One is total cholesterol. And the first thing we really look for is low total cholesterol. And if you have low total cholesterol, we want to know why. Because there are really 2 reasons, because that's the unhealthy part of cholesterol, having low cholesterol, is either your liver function is impaired and you're having a difficult time making cholesterol and transporting it onto the LDL particles, or your cells are hungry for cholesterol and are recycling cholesterol a lot. And so it's consuming a lot of cholesterol and sucking it out of your blood supply. So he's now lowering cholesterol. So the question is it from his liver or is it from his cells? Chances are his cells, because his cholesterol levels, his phosphatidylcholine levels are great. And so his HDL level's gone up and his peroxisomal function has gone up. So this is indicating that he's actually recycling cholesterol quite effectively. Like he's making it because his peroxisomal function is good and he's getting rid of it. And that's causing recycling. So nothing really to worry about here based upon his profiles. And then finally, we will look at his kidney function, but basically it's creatinine, blood urea nitrogen, uric acid. And his creatinine is going up. I know he's taking more creatine supplements, so that would contribute a little bit to that. Uric acid is fine, blood urea nitrogen is still fine. So here we keep an eye on this. This is not uncommon if you're exercising a lot, because if you're breaking down muscle material or if your muscle fibers are being recycled a lot, you can get high levels of creatinine. So we'll keep an eye on this. I'd like to see this come back down. Ideally for a man, we want to be in that 1 to 1.2 range-ish. Okay, so that's where we are. So overall, pretty cool. So the carnitine is what really, and the N-acetylcysteine is probably what gave him his mitochondrial function back. That's what fixed that mitochondrial function, like clockwork typically. The Prodrome Neuro restored his DHA levels and his plasmalogen levels, as well as the reduction in his oxidative stress. So that's what caused the C-reactive protein levels to come down. That's primarily what we see over and over again in individuals. And so from here forward, we're saying we're close. We're going to optimize him a bit more with some ethanolamine supplements, and let's make sure we'll keep an eye on this creatinine. So that's kind of how it works. So that's been Greenfields before and after. I hope you enjoy that. Before I leave you, I'll give you a couple teasers of some things that are happening on the horizon. I have a book coming out called Breaking Alzheimer's, and this is my crusade for the last 15 years looking at Alzheimer's disease. And so I'll tease you with 2 figures. The first one here is, and it's about plasmalogens, but plasmalogens aren't the only thing. It's really, if you have a loved one, or if you're worried about mental health and understanding Alzheimer's, what the biochemistry of Alzheimer's is, where it comes from, what people are at risk, what factors influence it. This is a book that explains that to you in very thorough language. It's scientifically dense, but hopefully it's explainable and understandable to each other. Here's an example. So we talked about these. This is the molecule that we just doubled or more in Ben's blood. Okay, this is the DHA plasmalogen levels, and this is a large population. It's 1,262 people for the study. Okay, so it's not a trivial study, and this is the probability of having dementia. And this basically says if a 90-year-old that has high blood plasmalogens, DHA plasmalogens in their blood, has less than a 10%, like a 7% chance of having dementia. But if that same 90-year-old had low plasmalogens in their blood, it's about a 40% chance that that person has dementia. That's a big, big difference. These are 95% confidence intervals. So from a scientific perspective, this is a very, very powerful finding. It indicates that people who have sustained high levels of plasmalogens in their blood have a very low risk of getting dementia. And then the next thing that was interesting, because we're interested obviously in longevity and mortality, is that above and beyond the role of plasmalogens in preventing dementia is the role they have in all-cause mortality. This is probability of dying in 5.3 years, okay, from the blood test. And this is individuals with high blood plasmalogens at their visit, okay, and this is with low blood plasmalogens. So again, for 5.3 years, so a 90-year-old with high blood plasmalogens, okay, had about a 75% chance of living till age 95. But a 90-year-old with low blood plasmalogens had just about a 20% chance of making it, almost an 80% chance of dying in the next 5 years. And so these are very extreme numbers. So when we're looking at more and more understanding the health of our population and obviously of our parents, these are things that most people want to know. So if you're interested, let me know. It's on our website, drgoodenowe.com, and this book should be launched within the next month. And I think that's my last slide. So thank you very, very much for your attention, and thank you, Ben, for testing and kicking the tires and being interested in your health and sharing your blood work with the world. I think it's exciting and it's fun. You can actually move these biomarkers where you want them. So with that, thank you very much for your time. Bye-bye.